In this video, we are going to start our discussion of linear equations in one variable. And so really all we want to be able to do is be able to solve a linear equation for a particular variable, including anything in context. So yes, word problems are going to come into our life again. We have missed them for oh so long, I know. And to get there, we have a few different things we need to be able to do. This video is going to focus on the first one, so solving linear equations using algebraic methods. We could also maybe see solving equations using a table too. We will maybe see a few examples like that in class. And then talk about absolute value linear equations. So in there, there's this little note here that we are not going to look at the equations that have like absolute value equal to absolute value. Just a little bit too complicated. You have to do it 4 times and just too much work that you never actually ever use it. And then in later videos, this is where we are going to talk about context. So we are going to see some of those pop up. But for right now, let's talk about linear equations in one variable. And this is just something that looks like, or that we can transform it into a form that looks like ax plus b is equal to 0. Again, it can be transformed into that. Doesn't mean it is that right off the bat. And so we have to have a not 0 and then b a number. Okay, and these are also known as first degree equations. So here we go. This says determine the solution set for each equation. Now the language solution set is a little new. All it means is solve it, and then you have to write a little sentence after, and then put your answer in a set. And again, we have seen those brackets pop up before when we were talking about set builder notation. So all that is going to come back here. Okay, so determine the first one. Okay, so we have to remember PEMDAS, right? So parentheses, okay, can't simplify inside parentheses anymore. Exponents, none appear. And then we go on to multiplication and division. And so the multiplication that we're going to do is really distribution. So distribute the 5 to both of those. I get 10x minus 5 on the left-hand side. The right-hand side, I get 3 minus 3x plus 5x. Okay, now on the right side, I'm going to combine those like terms, as we know all too well. 2x, 10x minus 5. Okay, and now I'm going to exploit the property of equality. Speaking of equal signs, this is just a general note. Here, you don't need any additional equal signs. Okay, mainly because we already have equal sign present, so when there's one present, we don't need any more. Okay, it just ends up being a little bit more confusing. So anyway, we want to isolate x to one side and all the non-x's to the other. So subtract 2x from both sides. Okay, and again, if you don't need to show this work, that is fine. I'm going to have it as 8x minus 5 on the left, and the right is 3. Add 5 to both sides. Okay, 8x is equal to 8, and then divide by 8, x is equal to 1. Now this is normally where you would stop, but again we want to determine the solution set, so all I'm going to do to conclude is a little statement saying the solution set for, and then whatever our variable is, in this case it is x, for x is, and then I'm going to put my answer in these brackets. Now ideally before I put them in brackets, I really should check my answer. Okay, and I can tell you I did this before the video and it does check out. Okay, so that's this one. Now our life becomes a little bit more complex as we want to do all this. Now there's many different ways of doing this. You could find a common denominator, and again, when you're adding and subtracting, that's when you need a common denominator. You could do that. I am actually going to multiply by the least common multiple. So if I think about 2, 4, and 6, I'm trying to think of like the multiples that they have in common, and 12 is going to be the first one that I encounter. So what I'm going to do is multiply both sides of the equation by 12. And again, like I said, there's many different ways to do this. If you don't want to do it this way, great. Find a common denominator, go forward. Okay, so and multiplying by 12 on both sides is okay because again, it is equal. I'm keeping it equal. can't do something to one side without doing it to the other. Okay, and so now I have to distribute this to both of the terms on the left-hand side. So I'm going to have 12 and then 4z minus 3 over 2 plus 12. And I'm writing it like this on purpose. You will see why. Over 4 is equal to, and then 12 include parentheses, 8z plus 1 over 6. Now the reason I did that is because now I'm able to reduce. Okay, so the 12 and 2 would reduce to be a 6 in the numerator. The 12 and the 4 would reduce to be a 3 in the numerator. And then on the other side, 12 and 6 would reduce to be a 2. So at the end, what I have here is 6, 4z minus 3, plus 3 times 7 is equal to 2, and then 8z plus 1. Okay, and again, if you went and did the common denominator, that's fine. You're going to get something that's slightly different. Okay, and I'm going to go ahead and distribute. I'm going to move a little faster here. 24z minus 18 plus 21 is equal to 16z plus 2. Subtract 16z from both sides, so I get 8z, and then this right here is really 3. I'm going to subtract the positive 3 over, and so I get 8z is equal to minus 1, and then z is equal to minus 1/8 as I divide by 8. Okay, so then I would conclude by saying the solution set for z is, begin set notation, negative, yep, that's right, negative 1/8. End set notation. Okay, and that would be my final answer. Okay, now again, you could have done this exercise, the second exercise, differently and probably obtain the same thing. The big idea is with linear equations, you want to get it into the ax plus b form so that you can say, okay, ax is equal to the opposite of b, and then solve for x by dividing by the coefficient of x. Okay, negative b over a, or something of that form. Okay. So, other things, remember no additional equal signs, and remember to read the instructions. Sometimes it'll say solve. In that case, you could stop at x is equal to 1. If it says solution set, then you need this sort of thing. Alright, so that's going to wrap up this video, and then next video we'll talk about absolute value linear equations.